Okay, so here are the notes for 1.7 day 3. We are continuing with solving absolute value inequalities, but today we're going to be dealing with some of the other information or special cases here. So the two special cases we have is when our C value is negative. So notice here that we have the absolute value of ax plus b is less than or equal to negative c, and then ax plus b, or absolute value of ax plus b, is greater than or equal to negative c. Okay, so when we have a less than or an and problem, so that also means that we could have just the less than symbol. It does not always have to have the equal bar. So this is what we call the and problem, right? Because it's less than. So when we have the less than, or we could have the less than or equal to inequality, and we have a negative C value, meaning that we have a negative number, what happens here is we get a no solution. So we're going to talk about more in depthly why we get a no solution. So just hold on, but for right now, just know that whenever we have the less than or an and problem with a negative value, it's always going to be a no solution. So now let's go when we have the greater than. So you could either have greater than, or you can have greater than or equal to a negative number. Remember, this is our or problem because this is greater. I'll spell that with an E, greater than. There we go. So when we have the greater than symbol and it's to a negative C, what that means is going to be infinitely many solutions. And so when we write this in interval notation, because it's infinitely many solutions, we're going to write it as negative infinity to positive infinity. So that's how you'll write your final answer there. There we go. Okay, so let's go ahead, let's start our first problem. Okay, we have the absolute value of x plus 1, which is greater than or equal to negative 16. So this is our greater than. Remember, it's important to know what the inequality symbol is because that will tell you if it's an or an and problem. So greater. So that means this is an or problem. So with this, we still need to solve because we still need to figure out what our variable or the values are. So remember when we are doing this with absolute value inequalities, we create two inequalities. So we create one that looks similar to our original problem, but without the absolute value bars. And this is or x plus 1. Now remember, the other inequality, we flip the sign and we do the opposite sign or negate the value. So since the 16 is already negative, when we negate it, it becomes positive. So now we solve for both inequalities. So for both of them, I subtract 1 on both sides. So I get x is greater than or equal to negative 17. And then x is less than or equal to 15. Okay, let's go ahead and do our line. And once again, remember, I'm going to be putting my numbers on the number line. So negative 17, that's the smallest, so it goes on the left-hand side. And then 15 is my biggest number, so it goes on the right-hand side. So left and right-hand side. Okay, so let's talk about what is happening here, because when we did our previous absolute value inequalities, we talked about with ors, right, they shade opposite directions, okay? But if we look at the inequalities that we have here, let's talk about x is greater than or equal to negative 17. Now remember, whenever we have an equal bar, that means we have a closed circle. Now I'm going to do this on top of this because what my final answer is, I'm going to shade that actually on the number line. So since this is saying x is greater than, really that means is if I want to go bigger, I'm actually going to shade to the right-hand side, okay? Now my other inequality says x is less than. So remember this is closed circle because we have the equal bar. But if x is less than, that doesn't mean I'm going to go to the right. It means I'm going to the left because my number should be getting smaller. Now notice here, this is an OR problem. But when we read our inequalities, they are not going opposite directions. In fact, they are intersecting. They are going in between. So because they are not going opposite directions, they're going in between. That's why in this case, we can shade the entire number line. So this is what you're actually going to do. So you want to shade the entire number line, okay? And that's why we get infinitely many solutions, because this is indicating that, well, we have x values that are larger than -17, or we could have numbers that are smaller. So that means we can have everything that's on the number line. So make sure when you're doing these and you're doing your number line, you shade the entire thing. And then to write your interval notation, because we're shading the entire number line, that means we have infinitely many solutions. So we go from -infinity to +infinity. And remember, with infinity signs, we use parentheses around them. Okay, so here's my interval notation. So this would be my final answer here. Okay, let's go ahead and try another one. So on our other one, we have absolute value of 2x minus 1, which is less than -25. So this is our less than. So it's an AND problem. There we go. So just as we've done before, okay, we're going to go ahead and solve this. So we have our 2x minus 1, so we create our two inequalities. So remember the first one, I make it look similar to what the problem already is. And then I have an and then I have 2x minus 1. I flip the sign, and I change the sign of the number as well. So I get a +25. Okay, so here we solve for both. On both of them, we add 1. And same thing here, we add 1. So we get 2x, and then we get less than, I think that's a -24. And then on the other one, we get 2x is greater than 26. Okay, now I divide both of them by 2. And so I get x is less than -12, and x is greater than 13. I'm going to put the and. Okay, so let's see what is happening here with the shading, right? Because we do have a special case here. We have an and it's to a -c value, -25. Okay, I'm going to put my numbers on my number line. So I have -12, and I have 13. Okay, so usually with our and problems, when we did the lesson before, that meant that we shaded in between. But let's see what's really happening with these inequalities that we see here. So just as I did with the first example, I'm going to go ahead and actually do stuff above the number line. And then when I get my final answer, I'll shade if I need to on the number line. Okay, so here's saying x is less than -12. So remember, we have an open circle when we do not have the equal bar. Now, because this is saying less than, that means we want numbers smaller than -12. Well, on a number line, to get smaller, we go to the left-hand side. Okay, now for this one, we have x is greater than 13. So once again, I do have open circle because there's no equal bar. But this is saying x is getting greater. That means I want numbers bigger than 13. And to do that, I need to shade to the right. So notice here, usually with ands, we shade in between because we want numbers that are that work or define both of these inequalities. But if we look here, actually our shading goes opposite directions. Now, if we think about it, let's just choose a number or some numbers. Let's choose like a number that is smaller than -12, right? Let's say -13. Well, we plug -13 into this inequality. Well, -13 is less than -12. That's true. But is it also greater than 13? So -13 greater than 13. Oh, that's not true. So that doesn't work. Okay, let's choose a number that is greater than 13, right? And I'm choosing these numbers because this is where we would shade in spite of what we have as our inequalities. So let's go with 14. Okay, well, 14 is greater than 13, so that restriction is true. But is it also less than -12? 14 less than -12. Well, that doesn't work. So because we cannot find any numbers on the number line that satisfies both of these inequalities, that's what an and represents, that it has to satisfy both of these inequalities. So since we don't have any of that, that's why in this case we have a no solution. So that means when we have a no solution, we do not shade anything that is on the number line. That's why I put it on top, okay? Because really there are no numbers that satisfy both our restrictions. On this one, because it was an or, basically our numbers had to satisfy only or at least one of these restrictions. So we could have one that satisfies this one, we could have numbers that satisfy the x is less than or equal to 15, or we could have a number that satisfies both. It does not matter because it only needs to satisfy at least once. So that's how we get our special cases. So if we have a greater and it's to a negative number, that's why we have infinitely many solutions, because all numbers satisfy at least one of these inequalities or conditions. With the and, the less than and problems, and we have a -c value, the reason we get no solution is because, well, there's no numbers that satisfies both of these inequalities or both conditions, okay? So I just wanted to kind of explain why we get these special cases. Okay, so let's go into the next problem. Just to let you know, really for if it's a no solution, you don't really have to do this work. You can just automatically say no solution. On the greater than, do show your work, because you do want to make sure, since you are shading on the number line, that you have your x values to indicate that. Now, if we look at number 3, we don't just have a number. So on number 1 and 2, we had negative values, so we kind of could already assume on the special cases if it was infinitely many solutions or no solution. But because we have a phrase here, we actually have to work this out to figure out our answer. So that means if we look at our inequality here, this is a greater. So this is an or problem. So we have two ways of shading. Either we will shade opposite directions, or we will shade the entire number line. And in order to know that, we will have to read our inequalities. Okay, so let's go ahead and set up our two inequalities. We have 2x plus 1, which is greater than x minus 4. Or we could have 2x plus 1, which is less than or equal to. Now, don't forget, because we have multiple phrases, we have to change the signs of both. So that means my x becomes negative and my 4 becomes positive. Be careful on that, okay? And then I'm going to do this as a different color for the or here. Okay, so on both of them, I'm going to go ahead and move the x to the other side. For my first one, I subtract x on both sides. On my second inequality, I actually add, because remember, I had to change the sign on this one. Okay, so now from there, I get on this one, just an x plus 1 is greater than or equal to -4. And then on my other inequality, I get 3x plus 1 is less than or equal to just a 4. Okay, now on both both of them, I subtract 1, so that one didn't change. So on my first inequality, I get x is greater than or equal to -5. On this one, I get 3x is less than or equal to 3. Now, I still need to do one more thing. I need to divide both sides by 3 to get my answer here. So now I get x is less than or equal to 1. Okay, so remember this is an OR problem. So we have one of two ways to shade. Either we will shade opposite directions, or we will shade the entire number line. Okay, so I have -5 and I have 1. Now what I'm going to do is actually do my work above, and then I'll figure out how to shade. Okay, the first one, I have x is greater than or equal to -5. Now remember, equal bar means I have closed circles, so I have a closed circle here on -5. Now since x is greater than, it looks like I want numbers bigger, so that means it looks like I would shade to the right here. Okay, let's look at our other inequality. This is x is less than or equal to 1. Okay, once again, I have a closed circle. Now I was saying less than, that means I'm going to the left because I want x values that are smaller. So if we notice our lines, they intersect. They go basically through each other. And because this is an OR, that means we have infinitely many solutions because any of these numbers on the number line could satisfy at least one of these inequalities. So because this is not opposite directions, that means it's going to be infinitely many. So once you have shaded your number line, so notice I shaded the entire number line, then you need to write your interval notation to -infinity to +infinity. So don't forget that. Okay, let's go ahead and do the last problem here. So on the last problem, we have 3 times the absolute value of x minus 7, which is less than or equal to -12. So notice this is a less than problem, okay? So because this is a less than, that means we will either shade we will either shade in between, or we could have no solution, okay? Now, before we can figure that out, notice that I have this 3 in front of my absolute value. If you notice, for all of our problems 1 through 3, we didn't have anything that was in front or in back. That means the absolute value was isolated. In this case, because we have something that is outside the absolute value, we need to make sure we isolate it. So that means in this case, before I even solve, I need to divide everything by a 3. So now I get absolute value of x minus 7 is less than or equal to a -4, okay? So even before creating your two inequalities, make sure you isolate that absolute value, because if you don't, you will get the wrong answer. Okay, so now if we look, we still have the less than inequality, and notice we have this negative, okay? So remember our special cases. If we have a less than and we have a negative C value, remember our C value is going to be a number, not a phrase, but a number itself. So because we have that in this case, and we really don't need to show work, this is just going to be a no solution. So you don't need to do anything on the number line, and for your interval notation, all you do is just write no solution, okay? So that's the nice part on this, because you don't really have to do work. So it is important that you know your two special cases, because it helps when you just need to figure that out. Okay, so what I want to do is I want to make sure we summarize the different inequalities, because once you kind of know what type of problem you're dealing with, you can basically decide between two things to figure what it's about. Okay, so let me do another page here and summarize. Okay, so here is our summary. Whoops, make sure I spell it correctly. Okay, so let's talk about when we have OR problems, okay? So this means when we have like the greater than or greater than or equal to. Okay, so the first one. So let's say we have our ax plus b, so the absolute value of it, and it can be either less than or, sorry, it should be greater than. So it can either be greater than or equal to, does not matter, a positive c. When we do this, let's talk about where we shade. We shade opposite directions. Okay. So if you have room somewhere to write this on your notes, I would do it, or you can write it on a separate sheet of paper. But I think you should definitely write this down because this is a great summary, and you can always refer back to it to figure out, okay, where do I need to shade? Because once you figure out what type of problem it is, if it's an or an and, you can really have like a 50-50 chance of figuring it out. Okay, so shade opposite directions. And remember, for interval notation for this, we basically go negative infinity to the c value. And then either we can use parentheses or we use brackets. So I'll do both cases. So this will be like negative c, and then you go from positive c or whatever value you have. Or it can look like something like this. So you can have negative infinity, our negative c value, bracket, and then bracket c. Okay, and so this is where we have the greater, and this is the greater than or equal to. So now let's talk about when our c value is negative. So make sure if you need to pause this to write it down because I'm going too fast, make sure you do that. Okay, so now let's say we have the negative c value, and it's still an or problem. So we have the absolute value of ax plus b is greater than or equal to a negative c. Well, what happens here, so we have our negative c and c, and I'm just making these random values. It doesn't always have to be a negative and a positive. It could be, you know, two positive, two negatives, just depending. We shade everything. Or we shade basically the entire number line. And so for interval notation, and this will be the same whenever it's you shading the entire number line, it will go from negative infinity to positive infinity. So anytime you have an or problem, okay, so anytime you have an or problem, if it's a positive c, that means you will shade opposite directions, and your interval notation will look similar to this. If you have an or problem and it's to a negative c, then what you need to do is shade the entire number line. Still make sure you solve for both of them. And for your interval notations, negative infinity to positive infinity. Okay, let's talk about and problems. Okay, so for this, let's say we have it where we have the positive c. So we have ax plus b, the absolute value of it. It's either less than or it could be less than or equal to a positive c. Well, remember when we do this, and once again, I'm just doing random values here, that means we would shade in between. Okay? So when we shade in between, our interval notation will look similar to this. So either we have parentheses, and that's when we have the less than, or we have brackets, and that's when we have the equal bar with our less than. And there will never be an interchange, so it's either all parentheses or all brackets. The other way is when we have a negative C value. So when we have AX plus B, and it's the absolute value, it's either less than or equal to a negative C value. This is where we just get a no solution. So that means you do not shade the number line because no numbers work. So we shouldn't be shading anything. So be careful on that. Okay. So I would really make sure, I'll scroll back up so you guys can see this part. Make sure you pause the video so then like you can write all this information down. And then here's your bottom part. So definitely make sure to write this down because it will help, especially when for tonight's homework, because it is a mixture of when C value is positive or negative. Now don't forget, if it is a phrase like we did on number 3, then you actually have to work it all out to determine how to shade. So if it's an or problem, then either you will shade opposite directions or the entire number line. If it's an and problem, either you shade in between or it's going to be a no solution. If you have any questions, make sure you contact me, and that's basically it.